Welcome to Mrs. Sau's Math World. Today we are going to discuss the formula sum to infinity. Please go to page 2.23 of the textbook. So let's look at what it is. Okay, so it is actually talking about a kind of geometric sequence. Okay, but the number of terms we actually don't have limit in it. Will you please have a look on this page and try to complete question 1 and question 2? We are going to see if in a sequence for Rn whether it will goes to 0. Go means very close to 0 when the power n is very large. So here is the answer key. Okay. So when you look at the R, which is close to 0, like this case, these two cases, okay, when the power is large, actually the value will be pretty close to 0, right? Why is it so important? That means if you are going to add a value, you add all the terms, okay, like this. That means at some moment you are adding something which is pretty close to 0, right? When it is pretty close to 0, that means you are almost going to add nothing at last, right? Because this one is very little, so you can say you can ignore it. Okay, so when you're almost adding nothing, that means we can add all the terms in this sequence. But for 3 and -2, we cannot, because when we add, like the first example, the number will go very large. It goes to very large, and it never ends. Okay, we don't have the sense of adding nothing at last. Okay, so that's why we get the formula here. So why we get this? Because when this one is very large, n is very large, okay, then the R is within 1 to -1. As in the last question, this one is almost 0. When it is almost 0, that means we write all the things again. So the upper part will becomes A, and the lower part becomes 1 minus R. Alright, so with the formula, we will change it to infinity. So we will get the formula as infinity goes to A over 1 minus R. So please go to page 2.25. So this is example 2.10. Okay, so in each case, you are asked to find the sum to infinity to each of the following geometric sequence. So this is the first one. Check the R, okay? So this is part B. The question is actually asking you to do 1 plus 1 over 3 plus 1 over 9 plus 1 over 21 plus forever. Okay, in this way. But the English just changed to sum to infinity for the sequence. Okay? Let's have a look on the answer. Right? So in each sequence, when you use the formula, find the first term, just copy. R 1 over 3 divided by 1, you get 1 over 3. So you get sum to infinity of the sequence. Just substitute A over 1 minus R, and then you can get the answer. So it also works similarly for a common ratio which is negative. But of course, it must be greater than -1. So step 1, find the R with a reasonable value. Okay, 8, -28. R, second term divided by the first term here. So you get -3 over 4. Then you can use the formula of sum to infinity. Make sure you calculate this correctly. Okay, you may use calculator to do so. Alright? So this is the basic setup. So sometimes the sequence will be like this. That means the key point is for the value of A, for the sum on infinity, in this case, you are going to find it unknown. For A, And for part B, we're going to find the unknown for another thing, okay? So, we just need to set up the equation as usual, just like finding the A, find the R by setting up an equation. So, let's look at the things that how we start. Okay, so the first thing is to find the R, the A is A, of course. So second term divided by the first term here. Second term divided by the first term. Okay, so the A is cancelled out in this way. So you see that we change it upside down because we change the division sign in the multiply. So that's why these two are cancelled and we get 1/5. Then the second important part is we use a sum to infinity. We know the value is 10. 10 is here. Okay, 10 is here. And then substitute, you get A divided by 1 minus 1/5. Okay, then multiply 4/5 to here, then you get A equals 8. So this is just substitute to get the result. Okay. Then in part B, you can see that this time we know the A. Okay, A is here. You can see that the value of A equals to 7, right? Equals to 7. So right now our task is to find the common ratio. Okay, we use capital R because we use small letter r in part A. Alright, so common ratio, second term divided by the first term. Okay, second term divided by the first term, then it's cancelled out, you get negative k. Okay, then after that, this is by calculation 1 plus k is given 4k plus 1. Multiply, then you get a quadratic equation. Then you must solve it. Okay. So when you check when do we need to reject the answer, please don't just look at this value. We need to put it back for R. Okay? So as a rough work, let me put the things here. When k is 3/4, R equals to negative k, negative 3/4. When k is equal to negative 2, then R equals to 2. Okay, we don't use the R here. Okay, so for case 1, case 2, we split it into two parts, right? Okay, so for the first one, R is equal to negative 3/4, which is in between the range. So this one is okay, we can use. But for the second one, R equals to 2, it is greater than 1, right? So we need to reject it. Okay, so that's why this time we only have one answer. But sometimes we may have more than one possible solution. So please pay attention when you are asked to find out. We must check the range of R every time. So this is the most important point. Alright. So these are the calculation stuff for sum to infinity.